From, it was Deborah Rollison, I believe, at the, wasn't it David, at the first cold fusion conference that suggested that there was an isotopic shift in palladium, and I believe Dr. Petrasso immediately stood up and corrected her and let her know that that was impossible.
Well, I was a speaker before her, and I had a theory on palladium transmutation. I claimed it was possible. I was very excited about her result, which, as you know, then became clouded afterwards. So my misinterpretation, I don't know if it's misinterpretation, at least confusion about the interpretation of the SIMS measurements due to overlapping lines, which is, having done all these SIMS measurements I showed you personally, with one graduate student doing half of them, I know the problem. Many hours. You have to take. That's something I tried to stress, and I think Dr. Mizuno stressed it in his talk too. That you have to make sure you have separation of these lines. The hydrides and everything else can come in. So the SIMS work is very tedious and notoriously uncertain.
But the fact you're doing it with 3 different methods, aren't you? You're not only using SIMS, and that's the key. You've got to do it with at least 2, and practically 3 methods, and then you know if you can really believe if they agree.
Well, the issue is whether or not the material found on the surface is being extracted from the electrolyte in the environment. Now, and everybody admits that that extraction can take place. So if you pre-electrolyze a cell and use a dummy electrode, you can extract and purify the cell. Now, do people do that? Do they do this pre-electrolysis, throw that electrode away, then put their active one in and see what's there?
You must also work in a Teflon cell because, of course, when you've done that, just what you just said there, the cell is going to go on leaking silicon out into the solution, and there are other things in the glass. Sometimes it's arsenic and antimony and so on. So you should really work in a Teflon. Highly boiled out Teflon cell, you'll see.
What about simply using the same material and finding regions of the, of the electrode that show evidence of isotopic ratio shifting anomalies, and regions nearby on the same electrode? For instance, in an electrode, looking at the center versus the outside, as a comparison, instead of trying to, sort out this question about, whether or not you're poisoning the, depositing the new elements from some unknown source.
But there is a problem there that the first atoms that go down, the electroplated, do not go down uniformly. I mean, there's always active regions on the surface that are more attractive to the first couple atoms than any other. And it's the first couple atoms that we're looking at here.
Right. But do you imagine that the process is a uniform process within that surface, on that surface?
No, it's not a uniform, not to start with.
Right.
It wouldn't be. It wouldn't even be if no cold fusion were taking place at all.
Right. So one ought to actually be doing a population study of the of many locations on these surfaces instead of just a few isolated spots.
Those population studies have been done by electrochemists for reasons which are totally different from what we're talking about. There are lots of theories of nucleation that's rather a forefront of some electrochemical work at the moment. And you can have a lot of counting of the actual nuclei and the spots, the number of atoms in the nuclei, nucleus, which is often incredibly small, like 20 atoms for the first nucleus or so. And that's all very well known. But I think the important thing, for example, in Russ George's work, if I understand it rightly, the whole thing was to see the difference in the isotopic ratio around these craters of spectral points. Is that not so?
Well, we're hoping that we have, a morphological clue on the material that says, one portion of this material is different than a neighboring portion. And what we stress is trying to find material that is consistent with no change in the material versus areas that show a consistent dramatic shift in the material. And that's, I think, the controls. In other words, I'm just talking about the control sample. It's always a question of your control versus your sample. And I think that there are controls built in to these samples. Every sample has within it your best controls. Right. And it's because you know, unless you think that this process is going to be absolutely uniform.
Yeah, but I would argue that there's a difference between your situation and the electrochemical situation. And in the electrochemical situation, you cannot count on a part of the electrode being a control, because the atoms, at least initially, will go to those certain active sites, independent of cold fusion.
Right.
And there'll be an inhomogeneity in the surface right off the bat. So if you lose any control,
well, in fact,
which point's the control?
Well, in fact, you know, I'm actually not looking only at my own samples, but at the, you know, electrochemical cathodes from some of the best, you know, experiments around the world. So we're looking at, and I think that within those samples, we are even seeing variations from location to location that are adequate to demonstrate control and hot site conditions. Now, I mean, unfortunately, I only just recently got enough resolving power, you know, instrument horsepower to do this work in a significant fashion, you know, where we could fully resolve, you know, virtually all important interferences. You know, however, even still some were named.
Brings up a theme I was going to toss out or question people to comment on what's been presented here as being present state of the art. What new things would you recommend that we do as a community now to get this back to a respectable field?
I think there's only one overwhelming thing, I think this I'll get general agreement on. The overwhelming thing is to be able to go into a laboratory and carry out the cold fusion experiment, which works at a planned time. That's the overwhelming requirement. We're still based upon the fact that we say, maybe, that's still our state after 5 years, and we can't guarantee to do an experiment at a given time, a given situation. That's very, very bad. And people like Ed Storms and so on who've written papers recently, erudite papers, with much of which I agree, indicating in very great detail what's necessary to a reproducible experiment. And if you take Ed's contributions alone, my goodness, so to speak, no wonder you don't often get one to work. So they'll have to write before it works. But we should very much concentrate on that. I've been saying this for a couple of years, that we should have a project, reproducibility. That's the whole point.
And I think reproducibility has to be in several labs, so
yeah.
We have to be able to do these experiments. Other people have to reproduce. Let's see.
Just a question, John, because that sounds to me like, you know, a year ago, if I recall, the way this meeting ended was the constitution of a committee to come up with a demonstration experiment. Could you say something about, I mean, did that committee ever meet or what?
Yes, it didn't go at all. It went between Tom Passel and myself for 2 or 3 telephone conversations. It was agreed that Tom Passel should chair the committee and that everybody should send their suggestions to Tom Passel. I then acted as a sort of coordinator of writing to people and saying, please send your suggestions for reproducible experiment to Tom Passel, and 2 people out of 7 sent the suggestions and nobody else sent them. So I sort of thought that wasn't so. And then SETI came in. I don't know if you know, Joan Atherton, what SETI is, but SETI is an organization which is administratively in Dallas, who do claim, I think, that George Miley will say something about reproducibility. And so at this point I said, well, it's been done, so we don't need to go any further. But now some doubts about the SETI reproducibility. Did you say anything about that, George?
Well, let's see. You need to divide the Jim Redding's back here. He probably should answer that, but let me take a first crack. There are 2 issues. One is heat production, and the other are things like I'm doing, which use the SETI configuration, but thin films instead. And the heat production, I think I'll leave Jim to talk about. I'm not up to date on where we stand on that, but as I remarked, I have 20 experiments that all seem to have worked thus far, so I haven't been suffering from that type of reproducibility. But now, if I try to do a single experiment like with nickel, where I have 3 different separate experiments all with nickel, I find that I do get variations in the materials I see due to problems of perhaps non-uniformity from bead to bead, location to location. But I think the important thing is typically you get the same product. So we haven't had in the transmutation area, we haven't had the same problem that Tom Plater's having of having to worry about manufacturers and who makes what. It seems like anything we put on thin film from any source tends to work all right in the sense that I've been reporting. So I'm very anxious to see more people try this because the thin film approach seems to have that advantage, and it also has a big advantage that you don't have many atoms there, and so you can measure what you create more easily quantitatively. I'm still pushing. I'm trying to get milligrams, absolute numbers for these, and it's very hard if the thin film happens to be inside a solid electrode so many millimeters below the surface to get an absolute concentration. So this is my sales pitch for that type of transportation. I need to get Jim to comment on that question since he's
the production. We still have, I think at this point, a large batch-to-batch variation in bead construction.
I can't hear you, Jim. Could you say
we have a large batch-to-batch variation in bead construction and output of each of the various configurations we use. We have a pretty fairly high degree of confidence in the reproducibility. I'd say 90-95% reproducibility rate. We mostly producing in the last year. We're coming out with a kit, an experimenter's kit, that we're going to be announcing in the next couple of months that will allow people to put cells in beads that we understand is obviously for cost. We'll get them seeing the reaction with a high degree of confidence. It provides some knowledge, know-how, and enablement to the inventor or to the purchaser of the kit to let them see the reaction take place.
Can I ask a question about McCoubrey and his test? Isn't there a test being carried out by Mike McCoubrey?
I would have to let Mike McCoubrey respond to that directly. Those tests are not completed at this point. They're still underway. So Mike would have to answer that himself.
In that reproducibility, you said there's a large variation. Does that mean that some don't produce excess at all, or that it's the amount of excess?
It's a combination of the configurations of the beads and the design itself. And we find that it has a lot to do with the, I should say, purity of the materials we use. We have to work in a very non-clean environment. So that has a big effect on the construction of beads. But we do have some batch variation in specific configurations. There is some manufacturing.
Jim, could you help us by speaking about twice as loudly? We can't hear you.
Stand up. We do still have quite a bit of batch-to-batch bead variation, and it's not specific to the design of the beads alone. It's also dependent on the design characteristics of the cell, plays an integral part of the production. So we're still.
I want to stress, he's talking about electroplated beads as opposed to buttered beads, actually. Jim, were you finished, or?
Yeah.
I have his hands, I didn't want to interrupt you.
Well, he's got a microphone now, so say it all over again.
Not quite. The ones that don't work, is there zero access, or is it
small access? There is zero access in the ones that don't work. We have a lot of variation in specific configurations of beads that we expect to produce. But that's not the only reason why they do not produce heat at this time. It has a lot to do with the design characteristics of the cell and specific impurities that are in both the electrolyte and in the metals that we use in the manufacturing process. So we, at this point, we characterize the heat enough so that we have 95% reproducibility
90% reproducibility, are you...
Say 95% reproducibility.
95%. Are you talking about one particular design which does that, or several designs together to come up with 95%?
A single design, the nickel, palladium nickel design, we have a 95% reproducibility rate. And that's, it has a lot to do with flow characteristics of packed bed design. Is very important in the operation of the cell, having electrical conductivity across the cell.
I think one of the reproducibility issues is really that everybody in this field who is an experimentalist is exploring, and they're trying different methods. So we all probably have, I mean, at least in my work, we have particular methods which work every time. But we don't run those experiments. That's not our singular experiment that we work on. We're ranging through a variety of territories, trying to discover more information about this phenomenon. So when we report data and it shows that it's not 100% reproducibility, that's indicative of our basic exploration mode of doing the science, not that the work is insecure. Right? And I think that's
I have to challenge that, Ross. I think you're being a little bit, I'm sure they're being truthful, a little bit optimistic as far as palladium and plasma fonts are concerned. I think that Ed Storms will probably verify this, that there are still data electrodes which you can't understand at all, that just don't work. And the last one worked, and the last two worked, and then one seems to be the same, but you get nothing at all, right?
Oh, that's right. There are criteria you can use to sort them into roughly working and non-working groups. But within a working group, there'll always be some that don't work, and within the non-working group, there'll always be some that will work.
Will there always be some that do work within the working group, though?
Oh, yes. So it increases the probability of finding in that batch significant amount. I mean, if you just take a random collection of palladium, you might have one chance of 20. If you do this pretest, you might have one chance of 2.
I believe we have...
Could I quote?
Yeah,
there were lots of hands back here before we got into this discussion. And I felt since we have 20 minutes left, and one 5-minute talk here, I wanted to watch time. John, please, though, I didn't mean to interrupt.
I believe we have a reproducible experiment with both palladium and with titanium, and it's not particularly material sensitive. And I'd be glad to work with anybody who's interested in trying it.
Could you hear that in the back? Maybe. Could you speak louder, John? Because that's very
Okay.
important.
I believe we have a reproducible experiment using palladium or titanium. It's not particularly material sensitive, and I'll be glad to work with anybody that wants to try it.
Bravo. Now, there was a series of hands back here.
Okay.
Let's see. I was going to catch this one first and work back.
What Bockris was saying about J.J. Thompson, another source, in case you do not know it, Professor Bockris, is Gustave Le Bon in Belgium, from the Belgian National Research Council. He gave a whole series of experiments where transportation was taking place.
What date?
About 1904. And they were done in the National Academy and shown to everybody, and they were either with electrodes or with discharge tube. And he was inspired by Nikola Tesla.
Thanks for that.
Thank you. Yes.
Well, George, are you free to distribute the sputtered beads to other researchers? That could be replication, focusing on transmutation.
I think that's what Jim Redding's going to do, isn't it?
Right, that's correct. Right. Part of the research kit is, well, the focus of the research kit will be on reproducing George's work, in addition to having a clean system and a clean cell, which will, give the researcher a high degree of confidence in the nuclear transmutations, let's call them. We'll also have a cell design and a bead configuration that specifically focuses on heat production. So they'll be both part of the same kit.
Ed?
I had 2 comments. First of all, stuff about how to get people to accept these ideas of your work. You're not generally, I think, going to be able to convince your colleagues, people your age, people who are in the 40s or 50s. and has had many decades of experience in quantum mechanics. Because it's never been the case that this has ever happened. But Einstein came out with his theory in 1905. It was the next generation that accepted his ideas. His ideas weren't accepted for about 10 years, and then only slowly. You guys, what your job should be is to try to teach the next generation, people who are like in college right now, so that in a few years there'll be a lot of graduate students interested in doing this.
I think John's done a marvelous job of bringing high school students into his lab.
And there should, I mean, I'd like to suggest that at the next conference, invite all these A&M students to come. You know, college students, grad students who are willing to listen, high school students. Because this isn't going to work. If you guys are going to meet secretly, it seems to me, in these kind of rooms like this, or go have conferences in like Maui, or like places where people aren't going to be able to get to, and nobody's going to see this, you're not going to convince anybody. The people who are most...
You're certainly welcome to start a conference. There's no barriers.
No, I'm just suggesting, just open this conference up for college students to come for free and listen and watch.
Well, we opened it up to you on your request.
True.
No, he's right, absolutely.
The youngest person here is this guy from Japan right here. He's 23. He's a graduate student. I don't know if there's one other graduate student in this place. This is
I
really
could afford to
strange.
bring mine. I have.
Sorry, nobody has any money.
Did you have another point? I need to speed on and get some
Well, this is the guy I want to hear from.
I think one of the things our antagonists do is make us say that there's one theory. And those of you who read Douglas Morris, he always says that the reason that this field doesn't exist is there's 20 theories. And I want to challenge that. We have theories of isotopic loading of the fuel into the metal. We have theories of catastrophic redistribution. We have theories of what destroys the metal, even when we get the reactions we desire, and the theories of the Coulomb barrier. And that has two effects. One is, I think the mere fact that there's multiple theories on separate subjects, it's not all about one Coulomb barrier, proves the field's real. And two, I think if we just try and forget those other issues, I think we're on weaker grounds.
Let's see, we need...
Am I loud enough without that?
Yes. What's your name, sir?
I'm Jim Dunn.
Right.
And I'm with the Center for Technology Commercialization. And I'm an interested party, particularly in how we can do exactly what John was just saying. Not only increase the credibility, but expand the technology, get more people working in the field and using products, and actually working with SETI and several other groups to actually bring out lines of educational products and benchtop research kits. So if any of you have a product or something close enough that you'd like to talk about getting out in the market, we'd love to talk with you. As far as what I'm going to do today, I just got this fax in from Bob Bush, and I don't know in 5 minutes how much we're going to get through, but he has gone and used his model to try and verify part of Mizuno's work that was presented yesterday. And I had Dr. Mizuno look over the theories here, and I guess they're close enough to be worth presenting. And I'll go through them real quickly. And I don't know how far into it we'll get. Basically, can you all see that?
With the charts.
Yeah. Basically, what he's done is reviewing some of the things with both Dr. Miley and Dr. Mizuno, tried to see if his theories and models can really demonstrate and show what and validate the effects that they have seen in their transportation work. And if you look at the two concepts of either fusion or fission and the reactions that are producing xenon, and that's what he focused on was the large amounts of xenon that were in Mizuno's work. What he's done is taken and done an isotopic analysis of the platinum, and what he's trying to do is show how those shifts might be accounted for with his model. And the two reactions that he's looking at in general, although these don't show the total components here of platinum 195 producing magnesium 24, xenon 134, and chlorine 37, and platinum 196 producing the same things with chlorine 38. And basically, I don't know about his anti-neutrino and neutrino part of this, but I think we'll just go through the basic approach that he used. He did some calculations, and these charts may take a little bit of, I don't even know if people can see them well enough, but basically he's going through and figured out for the different isotopes of platinum what effects you might get, and you know, done quite a bit of work in working through the different isotopes and their abundances. This will all be published in the proceedings, I hope. I don't know exactly how.
Only if Bob Bush puts it together so we can publish it.
Okay. Well, not from the facts, I hope, but anyway. So some of these, so anyway, he's going through this in such a way that he, you know, used his model and calculated all the breakdowns here. And again, we don't have enough time to really work through this, but then he's analyzed from that and come up with his own little approach here. And this slide, unfortunately, is probably going to be very hard for people to.
We can't read it, we can't understand it.
Okay. Well, anyway, he's determined what would be the naturally occurring value of all the different isotopes, and then he's calculated what he thinks the new transmuted value would be. And then he's worked out a factor to normalize that over to Mizuno's, and then to see, starting with 1 that he normalizes, if that relationship carries all the way through by creating this extract that he then uses to normalize all the
Could I
rest.
comment on that, since I talked to him briefly about it, and I've studied the fission of uranium basic theory years ago. I've forgotten most of what I know about it, but I have, in that theory, first of all, you know, you get this famous double hump curve and so on. You can predict that with great difficulty using isobaric states and various things. To predict the isotopes, not the elements, you can predict elements, but to predict the isotope breakdown is not theoretically, we aren't theoretically capable of doing that at the moment, to my knowledge. What he's done is just that for platinum. He's assuming fission and predicting isotopic products from the fission. And if so, it's a forefront result, because I guess talking about spin-off, if we believe that these elements are coming from fission, and we understand that fission in solids is actually going to help us understand fission in uranium. I don't know, Bob, you also know something about fission, don't you? You trying to comment? Okay. Yeah, I'm sorry.
Well, I'll just make one comment. The thing went by so fast that, of course, it's hard to see much, but it looked to me like 5 neutrons got converted into protons along the way. And that, you didn't just fission something, but you actually converted neutrons to protons, and I find that surprising. And the reason it was done, of course, was because nobody has been able to find radioactive products. So everybody has got to force things to lead to non-radioactive products. But I think that that's a great weakness in the field.
Well, I hate to disturb your thinking, Joe, but you must remember that the most famous case of finding radioactive products was done in your own department by Kevin Wolf.
You say that, John, but Kevin Wolf has never reported that.
No, but it's
The only
surprising.
reports we've ever seen about that have been program officers who come and give talks about what scientists have found, which I also find a little surprising.
Well, actually, it's
But
his
here,
sponsors.
coming back, you know, let's just come back to the first or second slide you showed, which showed platinum going to magnesium, fluorine, and xenon, and they were all stable isotopes. By its very nature, requires neutrons to change into protons. Okay, that costs us a fair amount of concern, I thought.
I'm just presenting this stuff, so.
I know.
Okay.
I know, but you have to take some responsibility.
Due to the time, I'd like to...
Okay, real quickly, let me just, then, his calculations in his model showed that he has come up with a very close comparison, and this is what Dr. Mizuno's shifts look like, which are borne out by what Bush's model shows. And so basically, in summary, he's basically saying, and he also goes through calcium and potassium and a few others in here. We don't have time to go through. I suggest that everyone read this, in the proceedings and maybe contact Bob Bush directly to have any more questions. Yes?
I have a little problem in that if you're trying to explain the experimental data using these theories, you have to have an absolute representation of how much material is made and know that your measurements are relatively correct. As far as I know, no one has achieved that state yet, have they? I mean, when you make these analyses, they're not referencing. You don't know how many absolute number of atoms you have, and you don't know, if you look at chlorine, that is related one-to-one with, let's say, xenon.
I don't think that they're there yet. That's what I was claiming to come close to.
That's right, that's what you're trying to do. But now if you use a theory that is trying to predict the distribution, that theory predicts it in an absolute way, and the data is in a relative way. How in the heck do you make a one-to-one correspondence unless you do what you're doing now, which hasn't been done?
Can I say something again, please? I mean, you guys don't want to ignore me, it seems, but
No.
the problem with you guys' model, the quantum mechanical model, is that you're assuming that there's something inside an atom that's stable, that's permanent. You guys think that there's such a thing as a proton and a neutron inside an atom, and that these things would never interconvert with, like, electricity. To me, that's a problem with what your guys thinking. As long as you guys keep thinking that, you're not going to understand this new phenomenon, because this new phenomenon shows that materials convert to electricity. When a moving plasmoid moves through something, like I said yesterday, the substance disappears. You can't find it. Where does it go? What happens to the plasmoid is that it gets bigger, or if it hits a conductor, it converts to electricity, or it converts to light. As long as you keep assuming that there is such a thing as a hadron, and that's distinct from a fermion, you keep having this idea in your head, you're not going to understand these results, and this is why you keep, like, floundering around like this. And like I say, I don't think you can ever understand this anyway. So,
Now, the time is moving on, and when I've been in an audience like this, and usually I end up being mad at the person who's coordinating because he didn't give me a chance to say something. So this is your last chance. I don't want anyone to be mad at me. I want to make sure that everyone's had a chance.
George, let me just take one last second and say that in addition to my interest in getting out, benchtop research kits and things that people can test and use firsthand, I'm also really hoping that we can create a project that I would call a nuclear battery. I'm in the process of creating an advanced vehicle technology center at the Griffiths Air Force Base in upstate New York for Governor Pataki. And he's gotten so excited about this that he's put $100 million of funding into his Environmental Bond Act, focused on zero-emission vehicles and the pollution issue. But I think there's funding that could be made available because the electric vehicle arena is moving along at such a rapid pace that we're already several years behind Japan, unfortunately. And Sony's put $350 million into the lithium-ion battery plant, and the nickel metal hydride batteries that are already being developed by Panasonic and others, are moving along at a faster pace than they are in this country, even though we have the Advanced Battery Consortium. So we're creating next week a high-performance cold climate battery consortium. And if anyone has any ideas, I'd love to hear about those offline.
Jim, what's the best way to make the link between this technology and the hydrogen and fuel technology that the automotive industry is now moving towards?
Well, actually, the fuel cells are making the best progress. We have a fuel cell powered program we're putting together with UPS for a UPS delivery truck to be fuel cell powered. We have fuel cell powered buses. These are all proton emission, hydrogen based, and we have a number of projects. There's a lot of common ground between the nickel metal hydride works, the fuel cells, and where we are today with the advanced membranes. And the cost of those are coming way down. John?
I'll just add one thing on that. Mercedes recently, about 3 weeks ago, said that they had plans for mass production within 1 year of a truck, a saloon, and a general purpose vehicle. And this is all fuel cell powered. Hydrogen as the fuel and fuel cells. Mercedes have been in the advance in Europe all the time.
Mercedes has just demonstrated over the last 3 months a fuel cell powered van. It's a dramatic improvement over the one they demonstrated 2 years ago. But we have Ballard.
Ballard is the most advanced in this continent.
Yeah, Ballard has made several fuel cell powered buses, and we have both Phosphorics and PEMs. But
because they're funded by Mercedes, but
right.
Now, I hate to stop all that discussion, but let's see, I'm trying to think. The people who have done the, I know, flame and those explosive type of reactions had some very interesting papers here. I haven't heard any discussion of that. No one said anything. Does anyone want to say anything about that area?
Well, those are difficult. I mean, I think if you're going to concentrate on anything that's reproducible, it has to be this electrolytic controlled cell. But what bothers me, I guess, with what I've seen, and particularly with what you've done, you always get something. So is there a situation where you have a null result, or are there just a lot of null results and we haven't seen them?
We'd like to find a null result. I didn't show data. I guess in my case, the good thing about always getting something is you get something different.
Okay.
What you should is you use some different base metal.
Okay.
So that's encouraging, but it doesn't really answer Joe's questions. I think Joe is a good one, good critic for us to listen to.
Well, I think Tom was asking, have you run beads that were never in the electrolysis? Done the same analytical effort on the
Well, we always, I mean,
on the virgin material?
Every bead,
That's
every
every
bead we make and then transmute, we always run the same techniques on the fresh one, and we always subtract that from anything else. We're always doing that. I think what he's asking, everyone is saying, can we put something on that would absorb impurities but not react? Do you have such a thing? Now, the closest we did, as I said, was sulfonate beads to get the conducting surface.
Well, I would like to emphasize the scavenger electrolysis. I used to do this in an extremely intense way many years ago, and I could tell you all the detailed techniques, but you can get, 10 to the -8 less impurities in 48 hours type of thing if you use a sufficiently large electrode to absorb it. You simply deposit all those impurities would have gone onto your electrode, and you have the Teflon cell. You then very carefully take the thing out that's deposited all the stuff on it. Be very careful that nothing drips back again. Whip it away, and after that, as long as you guard the cell from the atmosphere, and for God's sake, don't let any room air get in, you've got a very, very pure solution. Yes. It's terrifically sensitive. I mean, somebody who has dirty air in the room, or years ago when they used to smoke, you had to go back and begin again for a smoke got it.
I'm well aware of it. Yes, John.
Do we want to talk about the patent office?
Yeah. Patent office. Anyone want to comment about the patent office? Did you?
Well,
Can you stand up and speak?
Yeah, we've been trying to get a patent for 6 years, and get rejected every time. We went to appeals once, and we lost there, but we refiled. Now we want to go to appeals again, but the patent office apparently doesn't want to let us.
So forget it. Seriously, forget it. File the patent. When the whole thing breaks out, when everyone in the world believes it, Congress will force the patent office to take up your case. You've already got all the documentation you could possibly want. You've got priority. Skip it. Just go ahead and...
But Jim, you've got patents, didn't you?
I didn't get that. My grandfather did.
So how did those patents come? By not mentioning cold fusion, I suppose.
Yes, I think that was one of the reasons. We had some historical background in the patent office in which to build upon some success on a progressive basis, but I think he didn't use the word cold fusion, and I think that was probably the...
Well, he referenced Fleischmann, didn't he, in his paper?
Yeah.
So he didn't really where it was.
We have claims now to excess heat patents. Ex parte dash is the patent office's traditional rejection of anyone in the field.
You're famous.
That's what they use. They use your case, John.
What to be famous
What I was suggesting was filing patents. Filing patents with new dates for new materials. It's the best thing to do. And now that there are some, there is some intellectual property that has been issued there's some precedents in which to have intellectual property right. Links to.
Comment over here.
I read your file folder. Your lawyer never answered the examiner in the appeals. That's why you lost.
That's what my new lawyer says.
Yes.
I'd like to say there has been some success in Europe too in patents because INCO has been successful with TF patents there. This is extremely unusual because usually the allowance is in the United States and then it goes overseas. But you see pressure coming back now from Europe, and it's building up.
What does that mean? Pressure.
Well, I can't get specific, but
well, when it came out in Europe,
those
there was a
guys-
6-month delay for people to protest. Is that what you mean by pressure?
no,
9 months.
no, it's not.
Bob?
Yeah, I was just going to say, if you file patents before the patent laws changed here, you should definitely not abandon that. You want to keep it alive in the patent office as long as possible because you'll get 17 years from the date of issue instead of 20 years from the date of file. And in this field, the real value of the patent is going to be 10 or 20 years down the road. It's not going to be in the next couple of years. So you want to just keep it alive as long as possible.
It's spendy, but that's what I'm trying to do.
Yeah, you can afford it. Costs money. Yeah.
Have you gotten any positive response from the patent office in any of their office actions recently?
Define positive.
Encouraging.
Less negative.
Less negative.
They agree to legal.
But yeah, yes.
Yeah.
It's pretty important because entrepreneurs are not going to be very eager to put their money into something that you can't patent. It seems to be somewhat a religion rather than a reality because patent doesn't help you very much in the real world, does it? You've really got to get the big company to come along and steal your patent. They'll pay $10 million to fight you in court and you've only got $50,000.
That's right. Patent's just a ticket to court.
It's actually useless without the technology which has commercial benefits. It's the only reason why you have patents is to protect that commercially beneficial technology. And so it doesn't have any commercial value, patents worthless. Unless someone else develops something that has commercial value, which you can attack with their patent. So we need something that's commercially viable or new.
Now, I managed to misread my watch, and I just realized that we actually have 45 minutes or more left. So don't give up. We can make another round of discussion.
You've sucked it all out of us, you see. I forced it.
Yes.
I have a question relating to a comment that David Hudson makes in the, I hate to get off of this food technology, but alchemy ties in perfectly with this. They refer to a tincture being made from oil of whatever, oil of antimony, oil of egg, oil of gold. And Hudson says that people who create artificial gold or artificial anything using alchemical processes, that the oil is sucked out of the system because the oil is imparted by nature. And he says that the big companies that buy gold, that they have a technique that they can examine material that comes in and determine if it has oil or if it does not. If it does not, then they know it was artificially made. Does anybody have any ideas about? Well, you talk about the.
What is oil?
You talk. Well, that's the point. They say they can extract it with different acids and different mechanisms to make this oil. And there's a guy in Dallas named Hans Nitzel, and he used to make oil of gold. And the gold that once he extracts it, the gold is very brittle. It's like it loses ductility or something. And I don't ever see anybody addressing that. I know it's kind of off topic, but you talk about the variances in the palladium, and that the samples are never the same. You always get different responses, and it might be that there's differences in the amount of this alchemical oil that they're talking about.
Well, since we're using technologies that can identify every atom and every molecule in the sample, and all we need to know is what's the what's the composition of the quote oil, right? We'll just look in the spectra and it's either there or not.
It's something that's talked about for years before we ever existed, so I don't see anybody ever attacking it from that angle, except maybe Dr. Cobb. He talks about
well,
alchemy.
except if you
And Monty talks about alchemy. So.
Yeah, it's a euphemism for something. What is it a euphemism?
I don't know. I'm not an ethnicist. I see the term, and I know Hans. I've seen the oil that he makes, and they claim that when you put it under your tongue, if you're having a heart attack, you can put a drop of oil under your tongue and stop the heart attack. That's what the literature says. And he knows people that say that.
I think we have a little fish
I'd like to ask my colleague, Joe Natowitz, who's now heard a day and a half of all this. Now, I think we all know Professor Natowitz is a very well-known nuclear chemist, and his write-up in Texas A&M book starts by saying that he does transmutation. Now, Joe Natowitz, would I ask you, having heard these papers, we all agree, as we said last night privately, some of them are better than others, but what do you think yourself, please express yourself, about this field and its validity?
I probably should be sitting closer to the door.
Try to be a scientist, Joe.
I mean, I try. I do try. And I think there are people in this room who do try, and I respect them for it. I think there are people in this room who don't try, and that bothers me. I think there are people in this room who are delusional, and I respect them because I think that that's a problem. But I must say I've seen some things I think are very intriguing. I think the work of Miley and Mizuno is particularly intriguing to me. I have some severe reservations about whether there are any nuclear processes. For some of the reasons that I just stated, I have a very difficult time understanding how these processes always end up, and I think always, I can say 99% of the time, if it will make you happy, John, with non-radioactive products. That's amazing to me. And I hear arguments about electricity and plasmoids and so forth, but I spent my whole life doing reactions in which certain quantities are conserved. And of course, I may have the mediocre mind that Hal Cox talks about. John is gentler. He talks about it as classically trained, and therefore unable to accept new ideas. But in fact, over my 60 years, I have seen quite a few changes, and I've been able to accept them. And this group has seen a lot of things which have developed as new ideas, and we have been able to accept them. So I think we could accept them. I think what I see here, if I mention the work of the people that I think is interesting, I'm probably insulting all the rest, so maybe I'll have to be careful about that. But I think Rotz, for example, has to be prepared to accept the fact that maybe his results are right. He stands up and basically apologizes for his results and kind of wishes they weren't that way, but maybe they're right. And he ought to be able to accept that. Monty criticizes it as the worst experiment he has ever seen. From what I've seen, I doubt that seriously. Kim is a very good theoretician who has put forth an idea which John has seized upon as a theory, but in fact it's a speculation. I have discussed that. Dr. Kim is, yeah, he's here. I have discussed that with Akram Muhammedjanov, who is a multi-body theorist who Kim knows very well. Akram has the highest respect for Kim, but he thinks that there's something missing from this approach, and that's something to be discussed. Kim himself pointed out that the way you work is you do the best job you can, and then you try to see how it corresponds to reality. Kim pointed out to us that even if the penetrability problem is solved, that there are a lot of other problems. I would comment on his theory, and he can say whether I'm correct or not, but first of all, it has no requirement of an environment in solid state. In passing, I would point out that most nuclear reactions have been studied in the solid state in the past, not in the plasma, as John likes to keep supposing. That the thing that Kim is talking about is related to an active area of investigation in nuclear science, which has to do with neutron halo states. And the nuclei which exhibit those are nuclei we call exotic nuclei because they are far from stability, and they are extremely neutron rich. And the deuteron itself may be a good example of such a system, I don't know. But beyond that, I think one's going to have a great deal of trouble working with stable isotopes as all of the electrochemistry is being done and taking advantage of these neutron states. Kim and I talked about that this morning. The fact that it requires it to be loosely bound means that in stable nuclei it would have to be up around 8 million electron volts excitation energy in the nucleus. So I think one would have to go far away from stability to find cases where this might be a significant effect. Still, it's an interesting idea. If I had to summarize the field, from my perspective, I would say there's some good people doing some interesting things that are worth pursuing. There are a lot of people who, for whatever reason, don't strike me as very serious or reliable. There's a circle the wagons mentality in this group which accords all of these people the same platform. And the credibility of the field is going to suffer significantly until there's some shakeout. Maybe I should run out the door at this point. That's my honest opinion.
Thank you. Very valuable statement. If I only make a 1 sentence or 2 sentence comment on it. It seems to me, however, that what you said comes down to a number of statements about theoretical nuclear chemistry, which you are centered upon, obviously, the present viewpoint in that field, classical viewpoint that you profess, and you find then that this and that really is most unlikely, etc., etc. Would it not be better to face the fact that face the discovery that there are a number of new facts, and we can agree about 3 or 4 of them, I think, which are in the 90% likely range as experimental facts, and then start orienting towards explaining them, rather than starting off by saying it's all impossible?
Well, I would certainly agree with that, but we first have to accept what the facts are, and then we have to ask ourselves, what do these facts mean? And some of these things which are presented as facts in support of nuclear reactions, to me seem undemonstrated as facts in support of nuclear reactions. They may be facts, some.
But what about the other ones?
The other ones I have to think about myself. And I'm willing to do that.
I think so long as we've got you to think about it, that's a great
There's another point that I tried to make before, John, which I think it bothers me a great deal. People are quite willing to overthrow the structure of nuclear chemistry, but quite unwilling to believe that maybe there's some problems with SIMS, maybe our understanding of diffusion, maybe our understanding of isotope effects. In other words, people are working from their own base of what they know, and our young colleague has accused us of that, and quite willing to overthrow an area which they don't know very well, because they think they know so well their own area. And I see a lot of that in this group. And so the question of, we might be able to agree on the experimental fact that certain observations have been made. We now have to ask ourselves the question, how did they come about? I have, with the possible exception of the tritium, I have a hard time accepting that nuclear processes can explain some of the things I've seen. But I certainly respect the work that's being done.
Good enough.
Right, while we have you on the spot, just ask a side question. Kevin Wolf's name's come up several times and he's not here. And people are still trying to analyze his old experiments, but he's never presented that himself. Why not?
Because, well, I think I have to let Kevin speak for himself. People, I mean, this is a field where hearsay and gossip goes a long way. Kevin is the only one who can make an honest presentation of his work and his thinking processes, and therefore I think he ought to be the one to do it. I'm not sure John would have to tell you whether last year when someone else reported to present Kevin's work, whether Kevin had been asked to do it or not. I don't know the answer to that.
Yeah. You mean his sponsor? Had reported
Kevin's work.
I agree.
Kevin was sitting in the cyclotrons normally a block away, but maybe he was offered the opportunity to do it. I think that's a bizarre kind of thing to have, you know, to have a third party get up and report on somebody's work.
Not an unassociated party, though. His sponsor. Right.
Using his reports and his graphs.
Yes. He provided, well, you can say that, but you know, that comes to ethical questions in my mind.
Yeah. It may come to, it may address an ethical issue, which is clearly the case, but it doesn't, but the issue remains that the person had full and complete access to the data.
And also, the originator didn't present it, didn't publish it, and didn't make it freely available.
Yeah, but that, you know, I mean, we live in a field where
That's the question I'm asking.
someone doesn't
why
do
didn't
that, should we then start to take his work and say, you know, this is it?
If I believed in it, I would publish it.
Yeah.
So I would hate to get...
Some people are much more careful about using things off the internet, John.
I would think that, are you not in some way Kevin Wolf's boss?
Oh, I hired Kevin Wolf when I was...
You're head of the Cyclone Institute,
boss,
aren't you?
and I am director of the Cyclone Institute. So to
And
the
this work
extent that a
was done at
faculty
Cyclone.
member can be bossed, John, I had a lot of trouble doing that with you. I am Kevin's boss.
But is it not true that you knew the work was done?
Oh, absolutely.
And you knew that radioactivity had been observed? And this went on for 4 years, and it wasn't presented.
I know
Is that true?
I have always known when Kevin was working in the area of cold fusion. Many of us, of course, got very excited about the possibilities and jumped right in at the beginning.
And he's a very good experimenter, right?
Kevin is a first-rate experimentalist.
So
He's also a first-rate scientist, and he has never presented his work in any.
Why did he leave the key step out of the replication attempts?
The key step out of what?
The key step in the experiment protocol out of the replication attempts.
He doesn't know what it is. Because he tried to replicate it.
Leaving the key
And
ingredient.
Kevin Wolf has presented the results to EPRI publicly. He gave a lecture there.
Kevin Wolf was supported by EPRI and his body. Kevin Wolf has never published his work, John.
Didn't publish it, no. Would you say
I
that's
think that
ethical?
says something about how people should use that.
Well, much of science is unreported,
I
but
want to
does
get
go
you
on
off
under
the hook a little
conversation.
bit, put somebody else on. I see David standing back here, and he's a good friend, but I just wanted to ask, it seems like NRL has not been able to get any cold fusion results in any of the experiments you've tried that were positive, any positive results, I should say. So why do you indicate that you still have an interest in it? Why haven't you given up?
Well, we have gotten some positive results. They showed those particle spectra and other things they haven't shown. But the world doesn't circle around NRL. The person has to look at the body of knowledge out there and the people involved and the questions of reputation and adequate equipment and calibrations and care and all the normal things that go into judging whether or not something new is credible, whether it's a fit force or polywater or cold fusion or whatever. And my own personal opinion, not the lab's position, is that when I look at everything that's out there, there are some things that I can't find a way to dismiss. I have no basis for thinking that the people involved are lying, and therefore therefore I think it merits attention.
Do you have any comments on why you, particularly your group, NRL is just the group where nothing ever happened?
That's not true. I
The
say
black
we-
hole of cold fusion?
No, John, that's not right. I showed you data this morning. I can bury you in curves if you like, which show that we've got some things that, while not reproducible, not controllable, we can't turn them on, turn them up, turn them down, turn them off, things like that, which we all want. We have not been able to dismiss either. So we call NRL a black hole for cold fusion. It's a fun play on words, but it's not right.
Well, I got a suggestion. 50 cathodes, roughly, on the order of 50 cathodes, according to Storms and others, you've got about 2 chances of success if you test that many. With 1989 knowledge. If, you can't take a time machine, but if you could perhaps produce 50 more and then triage them by some of the methods that Storms and others have subsequently developed, you might have better luck.
Oh, absolutely.
It's a luck of draw.
Well, but I said 50 cathodes were produced. I thought that was the answer.
Yeah, that's what I was asking.
And some of them went to Mel Miles,
Yeah.
and he recorded and will record in Japan XSE with some of them.
Well, that's good, that's good. No, but I'm just saying that, if you could bring up to date, if you could start over again and use the knowledge that's now available, you might well have better success. I mean, it's not fair to hold you to, today's standards.
Now, I appreciate that comment. All of us work with what we have at the time, but the point is that we're not without success either in-house or the materials that we made elsewhere.
Well, that's important.
Yes.
Sitting behind Joe Nazareth is Dr. Mizuno. And Dr. Mizuno is a prominent researcher in Japan. And I'd like to ask Dr. Mizuno, who's been rather quiet most of the conference, to tell us a little bit about what his impressions are of this conference and whether he sees any marked advances in the Japanese scene, which he must know quite well, which he'd like to tell us about. Got a microphone, someone?
Doesn't work.
Don't stay.
I've lost, forgotten the question. The NHE program continues to pursue studies of XNC only. They have not looked into the cathode host metal transmutation issue at all. That's the first thing. And if they pay any attention to this meeting at all, perhaps they will, for the first time, take seriously the possibility of host-metal transmutation. But there has been no consideration of this whole issue at all, in spite of the fact that his paper came out, what, a year? Yeah, he's been ignored in his own country, unfortunately. A prophet without honor, I guess. What else was the question? I forgot.
Do you know anything about Raifu Notoyo's work? Because she put in a paper with about radioactivity from her electrodes.
Well, he was surprised she didn't come, but he doesn't have any communication with her at all. That's the answer to that.
Tell us.
I don't know. He was asking whether you were asking radioisotope production. Actually, I asked him about that, and he said that the cathodes that he used in the experiments were very old, 3 years old, so if there had been any radioisotopes, they would be long gone, unfortunately.
But according to the radioisotopes, I examined the proton conductor, very high semiconductor, here. That's the evidence materials. And at that time, I sent my data to hydrogen energy they upgraded my data. I found platinum 197 is a better emitter.
Oh, yeah.
So I detected after reading one day. So that's platinum 197, very short time.
18 hours?
18 hours.
Yeah.
So it's very difficult to detect. Maybe the radioisotope detection is very difficult. So maybe I can say the radioisotope produced by the collision reaction, maybe it's a very short time drive radioisotopes. So this time I presented my reaction product, the Pluto and isotope abundances. So I can say the increasing abundances maybe means that it has a very strong combination, so very stable. So maybe I can say the production of the, such kind of electrochemistry reaction induced constitute material may be very stable material. So it is very difficult to detect such kind of radioisotope material. This is the main reason. I'm sorry, I cannot say very clearly.
Jen, one quick question about the status of the contemplation work with Toyota.
The only thing he said is Kunimatsu reports they're still working there. There's very little information gets back and forth. Japan is a highly insular country within the country. That's one thing I can say about Japan. We'll talk to one another.
I would like to point out something about the Japanese work that I think is very relevant, and I speak here as an electrochemist. Now, I have some rather detailed knowledge about the Kunimatsu laboratory. I know a lot of the people in it, and 2 or 3 of them have worked with me and so on. And the point is that at the present time, there is no person in the, at least this is a statement about 3 months old, at that time there was no person in the Kunimatsu laboratory who was an electrochemist. And this seems to me very unfortunate. It's rather like having a radioactive lab in which nobody had any training in radioactivity, or a nuclear lab in which nobody had had training in nuclear chemistry. So I think the first thing that should be done to revise that is they should have 2 or 3 electrochemists, whom the University of Hokkaido nearby, 20 minutes away, produces many.
Okay. Yeah, that's right. You're right. There are no electrochemists because they said anyone who wants to come here and work should just do it. You know, they left it open to volunteers and no electrochemists volunteers. Very good.
Okay, now I want to say some words. The meeting is for me very nice. And I want to shift gear. Now, for me, this year and the last year conference was just a comparison. We can see that person attending conference like 50% more, and the paper also 50% more. You can see a larger new face, new group. So I think now maybe the time to have some kind of professional society for this kind of work. So I put a suggestion to the table that everyone discuss is we have such a society here. Thus we have more good publication or network or conference or it's much better join each other. That's my suggestion we can discuss.
These things have to grow up spontaneously. I didn't find that the little initiative I tried to make last year fired. It didn't fire. I don't know, but let's hear what the discussion is. What's the enthusiasm for making some kind of a, quote, society, unquote? No?
I'll volunteer a journal for the publications.
You have email, you don't need that.
We haven't got any money to spend. It's a little bit difficult to have a society. We wouldn't be able to charge the travel to any grants.
Well, I think it's sort of counterproductive anyway. I think there are plenty of good scientific societies that we all belong to that are perfect venues for this stuff. It's a struggle. You know, it's a fight to get information out in this field, and publication is not the only means of appropriate scientific communication. It's sort of the last means, really. And I think, you know, just normal collaboration amongst people who find some common interest is the right way to go at this point. And fortunately, with new electronic communications, that's become, you know, quite an easy process.
In fact, mention the Journal of Scientific Exploration. Journal of Scientific. Was it the Journal of Exploration? Scientific Exploration.
Journal of Scientific Exploration.
Yeah. Well, they published a lengthy review from Red Storms and a much briefer review from me. And they're quite open to these things, or indeed to practically anything which can be looked at in a scientific way. Very broad.
Yeah, it's a very excellent journal, but unfortunately we're tarred by other people's feathers in that journal. I mean, they do a very excellent job, but they have articles in there that many people would find hard to accept.
It's like this meeting,
yeah.
We're all coming out tarred and feathered.
Well, I think their attitude is that so long as it's discussed scientifically, they'll take on anything. Dividing.
They do a good job of editorializing, review. I mean, they're first-class papers in there. Their subject matter, however, is something that's hard for people to accept. I mean, like articles on dowsing. Well, I mean, okay, it's probably a real phenomenon, but a lot of people don't believe it.
Controversy.
I think that's they tend to go toward those things just for the reason that they want to know whether it's factual.
Yes.
And after that, well, yes, but
if you push the frontiers, you never discover what's there. If you don't push the frontiers, you never know anything other than your own backyard.
I've been to 2 meetings of the society, and the people I've met there are very sane, sound scientists. People like Peter Stark, who's a mechanical engineer who goes into aeronautics, and he's typically typical of the society. He's the president, very sound chap.
Let's say going back, Dr. Lynn's suggestion doesn't seem to have gotten much positive response yet, but can you comment more on what you had in mind? Are you thinking about this being a topical goal within, say, American Chemical Society?
Yeah.
Something like that?
Yeah, I thought, like, for example, the meeting, we already have 2 twice now. Is next year want to third time, or just stop here, or if we have some group that we can continue, for example, have meeting, have publication, have the internet, or now, I don't know about the next time. For example, you already have 2 twice now.
George, would it be possible to get this as a topical meeting at A&S?
Well, it could be topical meetings for others.
Yeah, if you go to the topical meeting, that's also good. Yeah.
I might mention one other thing, just to extend the comments that John has made, that we in fact do have a society already existing, and that's the Society of Scientific Exploration, which publishes this journal, who are looking for members. And they have an attitude of truly that which we idealistically espouse for science, and that is to look at where in the darkest reaches of nature and see what we see with an open mind. And they have that attitude, and they also have the scientific discipline that we would require for that attitude. And they're looking for membership. Now, if we wish to join a larger group and add our efforts to that, they would be very willing to accept our presence there.
Yeah, we get recruits too, I might add. That's where you're going to find people who are willing to replicate these experiments.
That's right. They already have an open mind. They've demonstrated that.
And I found I published 2 papers there, and they referee them all right. I've had a lot of referees' comments and asked for they may be changed quite a lot in one of my papers. I don't know how they treated your review, but did they ask for any review?
Yeah, they reviewed it.
Did they just say, well, that's fine, or did they want to?
They pretty much left it alone. They changed the title. They didn't like a critical review. They wanted it just a review. And didn't think it was very critical, but...
It did such a good job, though, John. There was little to challenge.
Well, it went through a lot of iterations. I mean, it had been editorialized a lot in the past.
What about the Hydrogen Energy Society? That's been in existence for a long time. It's got its feet on the ground and costs about $60 a year.
Well, I was one of the founders of that society, and it's doing very well, but I'm not too sure. I certainly think they wouldn't be against us, but they're doing so well at the moment that they probably wouldn't be all that interested. Whereas Journal of Scientific Exploration, I have a feeling, is grabbing for members. And they're very much smaller. The Hydrogen Energy Society has grown immensely and meets in all parts of the world every 18 months or 2 years.
They have a good journal, I think. I think that's
yes.
a good place to publish.
Barry, what's your question?
What?
Meeting. Tell us.
Given that I'm probably the only one in the room that doesn't believe in the... I'm certainly impressed, especially by Miley's data, Mazina's data, the others sort of, I mean, you know, it's very impressive, you know, and I think the only thing I would say is that that's great, and what I would like to see going along with it, and it's there to some extent, is a really good control of some sort. It doesn't have to be a blank, necessarily, in terms of no effect, but a control of some sort. I mean, that's, you know, once you have an effect, you have to have a control to be sure that you're seeing something other, you know, so, I mean, I've talked with Dr. Miley about various ways one might try to have a control experiment in these isotopic shift studies, and that's the thing I would really like to see, but yeah, I mean, you know, I don't have any problem with it, and it's definitely sort of changing my view of the field. So, and I work on hot fusion for a living, okay? So I admit it.
Still?
That was good.
Well, I'll quit tomorrow.
Let's see, we asked about what's happening in Japan. I don't know, does anyone know about any new events in other international community? Russia, for example. Anything new in Russia? Let's see, Tom, you were talking something about Russian tritium experiments.
Well, the Russians have several groups. They're still working at that, and Roman Donov has sent me several letters claiming all sorts of enhanced effects.
I read his papers. He's got tremendous production.
That's right. That's right. He also has a tremendous background of tritium, and so I have to kind of balance that off.
Where does that come from?
It comes if you don't purify the gas from these plants just is very it's got 100 times, 1,000 times more tritium than we're using. And so what we've ordered, you know, this deuterium we're getting is like $2,000 for 1,000 liters, which is far more expensive, but has so much 1,000 times less background. And so they're using the normal gas, and so if you have a tritium hideout and things in the system, you could get some effects. So I wonder about that. But McCoubrey's gone over there, looked at their experiment, and says probably we should go visit them and see what is going on. And I have the feeling something to it because I've done so many experiments.
What's that method?
That's almost the same as what we're doing, but they have a slightly different configuration for loading. So it's a plasma loading experiment.
Similar scale?
Yeah, very similar. Yeah, 1 centimeter sort of diameter. There are a number of other Russian cold fusion wannabes. They apparently have several different sites over there, one in their weapons arsenals. And I don't know that they've gotten funding. This one that I showed you is being funded for about $100,000 a year. And then there's 2 other groups, and they have interesting results, okay, definitely. And
Tom Passos told me that he thought the Russians had more innovative experiments in his view than anybody.
They seem to have the freedom, because nobody's looking over their shoulder, they're still paying them to go and try some other sort of innovative approaches like that. So
I think this is true of the
if they could,
Italians.
if they could get out of the country, that would be nice. If they just for the pay.
Yeah, about Russia. So, do you have any new information?
No. What's happened to the Russian experiments, the early ones, the plasma, ones which produced this large array of elements, correlated, is similar to what we're talking about, Zunos and so on. That seems to have not been carried forward.
No, it's wrong. So it's carrying on some kind of, low profile work. But actually, the very beginning, we had exactly the same problem as you have. So it looks like there are some kind of results showing that new elements, whatever else. But to tune away from all kinds of contamination, from transport, from the walls, whatever else, it's such a huge job that to do it correctly, it takes, forever, let's say.
McCoobie told me that he had met Samaki, your colleague who worked, the woman colleague who was in your group. And McCoobie said he was very impressed with her scientifically. This was 1994, I think, his visit, and that the work was going positively, etc. at that time. This was McCoobie's message to me. He'd had a detailed discussion with Samaki.
It's going on. I talk to them nearly every week. They work and they get reproducible. We had it, let's say, 5 years ago. They still have it. So they have reproducible excess heat results. So.
But the transmutation, what about the transmutation?
As I say, I'm, let's say, 50% confident. Maybe yes, it looks like it, like the answer is yes, but the confidence level is not that high as I would like.
So what are they doing to cure the impurity problem?
But as I say, it's a lot of work, a lot of analysis. So you must analyze not only your electrons, let's say cathode, anode, gas. You must also analyze all the possible transport reactions. So let's say whether it's electrolysis or it's a gas plasma, you have a transfer from your walls to the cathode, and the same thing because it's ion transfer, and particularly all metals have very low ionization potential, so you have a very probable situation of ion transfer right into your cathode. So because of that, as I say, before you analyze to a good level of confidence all the walls, all the impurities in the walls, until you estimate the amount of impurities which can be transported to the cathode, it's still a speculation. So when you do all this, then probably confidence level will go up. But until you do that, you can speculate.
Are you happy with isotope ratios as a key indicator of a reaction?
No, there are too many transport processes, either in electrolysis or in the cathode, that can actually produce isotope separation.
Even in the high Z's?
Whatever. Because actually, one of the methods of separating isotopes is to use the palladium foil. They are notorious.
Yeah, but
it's one of the commercial methods.
You have to do it 20,000 times before it has any measurable effect. It doesn't work just once.
It's not like that.
Oh, yes. Well, only hydrogen, deuterium, and tritium on one pass will get you anything above 1% separation. All the other metals, well, I don't know about lithium, 6 or 7, but as you get to higher atomic weights, the difference that you get with one electrolysis is very, very tiny.
in related questions, it always that the heavier isotopes lag behind? I mean, is that always the way it is? So
the heavier isotopes don't deposit so fast.
Okay, John, this is not the case, well, at least with the low discharge.
With what?
With low discharge situation, this is not the case. Because it's well known that you have, okay, when you bombard your surface with ions, you have a formation of dislocations. And the major diffusion mechanism is not your normal, quantum hopping. This is just a dislocation of transport of elements. And you won't believe, but we did this experiments long ago, maybe 15 years ago or something. But diffusion and transport of heavy elements in the same palladium or molybdenum or whatever else is enhanced by a factor of 10 to the 6. So this is not the case.
On the other hand, you start with a diffusion coefficient of 10 to the minus 40. Even 10 to the 6 enhancement doesn't get you very far. Delta squared equals 2dt. If you make a few calculations with Einstein-Smolakowski equation, you find that the ion moves about 1 angstrom per year or something like that.
All right, but the temperature is not room temperature in this experiment.
Oh, well, most of these experiments are done at more or less room temperature.
We're talking about two different things.
But again, is the segregation is still always that the heavier guys lag, right?
No.
No?
No.
In electrolytic deposition, it is true that the heavier ones lag.
I'm just wondering if in your in plasma, but in your data, are the shifts that you see corresponding to heavier things lagging, or it's not really like that, right? I mean,
Well, the shifts are so huge that I don't think it's worth. It's a tenable discussion myself.
well, if there were some bizarre enhancement of the diffusion process, at least it would still presumably preserve that the heavier things lag the lighter ones. I was just wondering if you see that. Or is it?
Well, I can't. I don't know the theory of the process inside the nuclear process, so I can't say what the isotopic effect would be. I only know something about electrolytic separation. I know something of the theory of that.
It's always a question of whose paradigm is being stepped on, I think. One ought to be careful.
But relative to checking transport walls, all those stuff, in our system, which we've gone to plastic, the main metal is an electrode and so on. We've done neutron activation analysis on all the components and are trying to do just what you say. Based on that, you can estimate what can come out.
Are you seeing a similar shift in the electrochemically deposited layers as you are in your plasma deposition layers? Of metal?
Electrochemical.
Well, you know, the beads that Jim Patterson makes, with which he deposits the metal layers on the bead through electrochemical methods, presumably, versus your method of producing of sputtering the beads, right?
We haven't studied those well enough to answer your question. We've done a cursory study, but because the coatings are so thick, again, we decided to use thin films because of the enhanced analytic ability with them. So I don't know the answer to your question.
When you made a transition to a cleaner system, did you see any change in the sort of impurity things you were detecting?
And when we've dumped silver and various things into the system, you don't see any enhancement in the film either. So we haven't found the smoking gun yet.
That's the way to go. I mean, you don't only have to purify it, you can also add into it.
Well, that's what I suggested to him, is that you should try spiking these things, the known impurity, maybe even a given single isotope.
Thiourea is a typical impurity you could add. And indeed, Dr. Spark has done quite a lot of work on the addition of thiourea. Interesting to know what happened with this type.
Got to try to have it. Let's see, time is moving on. Last chance for any additional comments.
I have one sort of question. I mean, we've seen like maybe 4 different presentations that measured isotope shifts and things like that. And in my mind, that's the most striking sort of new development in this area is, you know, before we were looking at heat or neutrons or tritium or something. And then all of a sudden, now that you look in the bigger picture, there's this stuff all over the place. between those 4 studies, or maybe just yours and Mizuno's, whichever, what are the similarities? What seems to be the characteristics of this effect?
Well, let me try to address that. I did that somewhat in the talk.
Right.
Now, at the moment, we're comparing apples and oranges.
Yeah,
Because
yeah,
I'm nickel and he has palladium. I have palladium data, which I didn't present here, which will be part of the
Yeah,
picture.
I mean, apples and oranges are both round, at least. So, I mean, maybe there's some similarity.
So I plan to compare the data in Hokkaido and also extend it to additional titanium, additional metals. And what I see still is what I said, there are these zones of products which are characteristic. We agree in the zones. The most striking difference are the gases, particularly xenon. I happen to have a comparison of the nickel data, which is apple and oranges. But, first of all, I don't know how to normalize his data against mine because I have milligrams per cubic centimeter, and I don't know how to do it. So what we did in this particular graph is we took the copper production and normalized his copper to ours, both here. It's a little hard to see. The squares are his and triangles are our data. But anyway, striking, xenon is way up here. In fact, it's divided by 30. We see scarcely any xenon, but my interpretation is fear not maybe diffused out of the metal because we have such thin films. There's some other things he sees down here, oxygen and so on. But a bulk, there's a zone here, zone there, and a zone there, which sort of agree.
And the zones get centered around what?
Well, I don't fully know, but depending on what the host metal is, the zones shift. As you guess, the higher the mass of the host metal, the higher the mass of the zone shifting up. So, I think there is a system. I tried to stress that in the talk. I think there is systematics that is coming out of this that will be very important for theories to explain. But I still have to. We've been trying for 4 months to get more quantitative data to completely put the purity business to rest. We don't have that. So at the moment, you still have to take this a little bit with a grain of salt. Yes?
I'd like to make a related response to Dr. Lin's question about how to continue. And I thought about this for all this time, and I myself am with the International Association of Planters of Humanity, and I feel this intuitive to us that the procedure that you started here has many good qualities, and it is autonomous, it is international, interdisciplinary, very fair, and has already found maybe not a perfect, but almost perfect method of publication. And it is also a networking organization. So therefore, these are all beautiful factors that make it worthwhile to continue the way you're doing it and grow from there instead of joining some other organization or whatever. And that's my opinion. I'm sorry.
So I think there's admirable characteristics are a tribute to the organizers, Professor Bockris, Dr. Lin. And since the time is up, I'd like to give them a final thanks. And
Dr. Lin's work.
thank everyone for their